Hello, our goal in this video is to learn how to compute the volume of a solid of revolution. In this problem, we are asked to compute the volume of the solid obtained by the rotation of the region bounded by the curves y equals x cubed plus x squared and y equals 0 around the x-axis, for all x in the closed interval from 0 to 2. When we have this type of question, it is important to have a graph of the region. This will allow us to learn more about the geometry of the problem and adopt the proper method to solve it. In this case, the region is bounded by the curve x cubed plus x squared and the x-axis. The axis of rotation is also contained in this region. This is important because it will allow us to use the disk method to compute the volume of the solid. This is the graph of the resulting solid. In order to compute the volume of this solid, we will use the disk method. As we can see from this graph, the axis of rotation is also contained in this solid. The shaded region on the following graph corresponds to the region that will be rotated around the x-axis to obtain the solid. It is clear that, for any x in the interval from 0 to 2, the radius of the disk is given by the absolute value of the function f of x. This is the distance from the axis of rotation to the curve y equals x cubed plus x squared. The cross-section area of the disk is given by the formula a of x, which equals pi times the square of the radius. In this case, the radius is the absolute value of f of x, which is the absolute value of x cubed plus x squared. The volume is given by the integral of the cross-section area from 0 to 2. This is the integral from 0 to 2 of pi times x cubed plus x squared squared. The volume is pi times the integral from 0 to 2 of x to the power 6, plus x to the power 5, plus x to the power 5, plus x to the power 4 dx. Using the fact that the integral of x to the power 6, plus x to the power 5, plus x to the power 5, plus x to the power 4 is 180x to the power 7, plus 420x to the power 6, plus 252x to the power 5, over 1260. So the volume of the solid is obtained by evaluating the antiderivative from 0 to 2. Evaluating the antiderivative from 0 to 2 of pi times 180x to the power 7, plus 420x to the power 6, plus 252x to the power 5, over 1260, gives us the volume of the solid, which is pi times 4832 over 105. Therefore, the volume of the solid is pi times 4832 over 105.